format, and then we try to discuss IP fragmentation and reassembly. So in this particular class, we will try to understand what's IP addressing and what is its significance, and then we will try to understand what are the different types of IP addresses. Then we'll try to discuss one of the topic called as network address translation, right? Okay, let me begin with IP addressing. Here, as I mentioned, in version 4, the length of IP address is 32-bit. So all the devices which are connected to the network are given a 32-bit IP address. The host as well as for the routers which are trying to connect the different hosts. As you can see in this figure, the different devices are connected to the network using certain connecting elements like routers. Each device would be connected to the network through a single link, which we call it as interface. So all the devices in the network or subnet will be connected to each other using an interface. Now for coming to a router, it is trying to connect multiple devices. So it will be having more than one interface. So routers typically will have multiple interfaces as compared with the connecting the host, which are having generally a single interface. The link that is trying to connect the device or router to the network, we call it as interface. The IP address associated with each interface is represented in 32 bits or 4 bytes. And what we try to do is each byte of this 4-byte address is represented with a decimal notation, and these 4 decimal digits are separated by a dots. That is the reason why we also call this representation as dotted decimal notation. Here you could find an IP address, for instance 223.1.1.1.1, which is actually a 4-byte or 32 bits, in which each byte is separated by a dotted symbol. Okay, so this is one of the examples of a network with each host device as well as the router connecting, given with different IP addresses. So let us look at this particular case where we are going to consider this is entirely called as a network, and here we are dividing the total network into smaller units called subnets, which is subnetwork. Here what is trying to do is we are trying to connect 3 host devices in one interface of the router, either using an Ethernet switch or a wireless access point. So the one interface of the router and the host, we can call it as subnet 1. Similarly, these 2 devices along with the second interface of the router as subnet 2. This is subnet 1, subnet 2, and the third interface of the router along with the remaining 2 devices, we call it as subnet 3. Now if you could observe the IP addresses assigned to the interfaces, you could find the first 3 decimals of the host devices and the router interface is same. The portion of the IP address which is common to all the devices in that subnet, we call it as subnet part, and the variable portion of each of this host along with the router, we refer it as host part. So your IP address will be consisting of network ID and host ID. Here we can call it as subnet ID and host ID. Okay, so subnet part indicates to which particular subnet belongs to, and the host part indicates to discriminate and identify the different devices which are the part of that particular subnet. So what's a subnet? As I mentioned, A device interfaces with same subnet part IP address and can physically reach out each other without an intervening router. So here we will be considering that there may be an Ethernet switch, or we may consider it may have some wireless access point through which all these devices are connected to each other without help of any different router. Okay, so subnet is a group of hosts and an interface connected to it. Is it clear? So device interfaces with the same subnet part. As I mentioned, we are calling this as subnet 1 part, and subnet part is this, which is common to all the devices in that subnet part. The variable portion is called the host ID part. Clear with it? In this example, this is subnet 1, 2 and subnet 3. Now we would like to extend our discussion of this subnet to the slide. Here you could find, to determine the subnets, detach each interface from its host or router, creating strands of isolated network. Each isolated network is called a subnet. Each isolated. Now I want to find out the subnet mask of this particular device. So the total length of the network ID part is called as subnet mask length. Okay, and to determine the first address, which is called subnet address of this particular subnetwork address, what we have to do is we have to keep the subnet part as it is, and whatever the host ID parts we have, that should be made as 0. This particular first subnet, if we keep subnet ID as it is and make all the host ID bits as 0, then we are going to get the first network address of that subnet, which is called as subnetwork address. Similarly, for the remaining two subnets also, make the host ID bits as zeros, we will get the first subnetwork address. In this example, we are extending beyond the 3 subnets. That is, as mentioned earlier, we have one interface of router and 3 hosts. The next case, you could find a bit of differences. Instead of one router, here we have 3 different routers. The first 3 hosts are connected to the first interface of the router 1, R1. The 2 devices are connected to one more router R2, and the third router is trying to connect the remaining 2 devices. Here the router is not only trying to connect to the devices, but you could find each router is trying to connect with the remaining router. So here R1 is trying to connect to R2. This is one more subnet. Already we have subnet 1, 2 and 3. Now along with this, we also try to create a subnet between R1 and R2 called subnet 4, R2 and R3 subnet 5, R1 and R3 subnet 6. So in this particular example, you could find totally 6 subnets existing. Am I sounding clear? So subnet is basically so this totally could be called as an entire network, and this total network is consisting of 6 subnets. Fine. In subnet, all the devices and the router interfaces will have a common subnet ID. Here you could find the router R1 and R2 are part of subnet 4, and they have the common subnet IDs 223.1.9, and their host ID portions are variable. Clear with this? Right. So the next thing we need to understand in IP addressing is the 2 types of addresses called classful addressing and classless addressing. The first type is called classful addressing, where we are trying to divide the total number of IP addresses available into different classes. So understanding this, let's look at this particular slide. The first We have learned in the beginning the length of IPv4 address. The length of IPv4 address is, can someone tell me the answer? The length of IPv4 address is 32 bits. Okay, so when your total length of IPv4 address is 32 bits, the total number of addresses possible is called as address space. And for 32 bits in binary, the total possible combinations are 2 power 32, which we are referring it as address space. Right. In classful addressing, what we are trying to do is we are going to divide this total 2 power 32 addresses spaces into different classes. So namely class A, class B, class C, class D, and a future reserved one called as class E. Okay. Now, the first half of the total IP addresses, that is 2 power 32, the first half, which is nothing but 2 power 32 by 2, which is equal to 2 power 31 IP addresses are allotted to class A. So class A is going to have total 2 power 31 addresses. Okay, the remaining 2 power 31 addresses is shared between the balance devices. So totally 500 addresses, 50 addresses are allotted to class A. Now, what we have to do to identify next, so in the remaining addresses, the half are allotted to class B. That is the balance 2 power 31, which are left out with total IP addresses, half belongs to class B. So it is going to have 2 power 30 addresses. Next, class C is having 2 power 29. Just give me a minute. Then class D is going to have 2 power 28, and class C is also going to have 2 power 28 addresses. Now, how to identify which address belongs to which particular network, for which I would like to first use this space. Okay, now let us begin with class A. Now totally, as I mentioned, we are going to represent an IP address in dotted decimal notation with the 4 bytes are separated by decimal symbols. Okay, now in the first byte, so we have 4 bytes. Let me consider the first byte of the IP address. In first byte we have 7 bits starting from B7 to B0, or you can call it as B8 to B1. Now in the first bit B8 is 0, then that particular set of IP addresses belongs to class A. So what do you mean by it? A first bit of your first byte is 0, and remaining bits can take any value from all zeros to all ones. Those are referred to be a class A. Now, right, so what's the starting range here? All zeros means 0, 0 followed by 7 ones. This is 127. So the first set, which is 0, 0, 0, 0, 0 to 127, and remaining 3 bytes which we have We have just talked about first byte, and the remaining 3 bytes can also have the values between 0, 0, 0, 0, 0 to all the remaining 3 bytes can also take one of these values to 1, 1, 1, 1, 1, 1, 1, 1. So the possible range of addresses in class A is 0 dot 0 0 0 to 127 dot 255 dot 255 dot 255. The reason is simple. In your class A, the first bit of the first byte is always 0. So its range is from 0 dot 0 dot 0 dot 0 to 127 dot 255 dot 255 dot 255. Right? This is about class A. The next condition is, here we have discussed the first bit of the first byte is 0. The first bit of the first byte is 1. The first bit is 1. Instead of 0, it is 1. Then we look at the second bit value, that is B8 is 1, B7. If B8 is 1, B7 can have one of the two possible values. The one possible value for B7 is 0. So if B8, the first bit is 1 and second bit is 0, then that series indicate the class B series. The first two bits fixed are 1, 0, and the remaining possible values are all zeros to all ones. So what is the range of class B addresses? It starts from 128 up to 191, and remaining 3 bytes can take values from all zeros to all ones. So we have the range of class B starting from 128 dot 0 dot 0 dot 0 to 191 dot 255 dot 255 dot 255. Is it clear? Right. Then coming to the class C, here the first two bits, that is B8 and B7, are ones, and the third bit, this B6, will be taking a value of either 0 or 1. But here for class C, the third bit is 0. So the fixed values is 110, and the remaining 5 bits can take values of all zeros to all ones. So the range of class C starts when you convert it into decimal 11000000. It's nothing but 192, and next 110 and all ones is 223, and remaining 3 bytes can take values starting from all zeros to all ones. So the range of the addresses in class C is 192.0.0.0 to 223.255.255.255. This is class C. And coming to the last or fourth combination, which is having class D. Here B8 is 1, B7 is 1, earlier B6 is 0, but this time the third bit is also 1 and the fourth bit is 0. Then it belongs to class D. But for class E, first 3 bits are 1s and fourth bit is also 1. It belongs to class E. First let us look at class D. If it is 1, 1, 1, 0, then the remaining bits can take a value of 0, 0, 0, 0. So remember, I am talking about first byte of the IP address. So the possible range of values for class D is 111000000 is nothing but 224, and 1111 . This 110 is nothing but 239. So the class D range is from 224 dot. The remaining 3 bytes can be 00000 to 239 dot 255 dot 255 dot 255. And last class E, where all the first 4 bits should be ones, the remaining 4 bits are in the range of 0000 to 1111. So the class E range is 240 to 255. Okay, so these are the ways in which we are going to divide the total IP addresses in classful addressing as 5 classes: class A, class B, class D, class D, and class C. Now, one more important thing that we need to understand in classful addressing is the length of network ID part and the host ID part. As I mentioned earlier, in classful addressing, we have two parts, which is one is network ID, the second one is called host ID. The network ID is trying to indicate to which particular network do we belong, and the host ID is trying to discriminate the different hosts which are connected to the network. Now, for instance, I belong to a class, so all my friends' roll numbers, we would find some numbers common with all the other friends, indicating we are of common year admission, common college, common branch, but different students. If I take a simple example of a student 18 AG1 A0, for instance 422, and another candidate of a number 18 AG1 A0 432. So here you could find some portion of the roll numbers is common to the both students and some portion is variable to each other. So they belong to the same year of admission, same college, same code, same branch, but different students with different roll numbers. So 22 is differentiating the another student with the number 32. So the common part we call it as network ID. The variable portion is referred as host ID. The same thing we will have in classless addressing, but there we refer it as prefix and suffix. Okay. In classful addressing, the length of network ID should be a multiple of 8. So for class A, the length of net and the relation between network ID and host ID length is host ID length is equal to the host ID length is equal to 32 minus network ID length. So the host ID length is 32 minus network ID length. So for instance, in class A, the network ID length is 8 bits or 1 byte. So the length of network ID in class A is 1 byte or 8 bits. So what will be the host ID length? 32 minus 8 bits. So in case of class A, the host ID length is 24 bits. And remember, this length is fixed in case of classful addressing. Okay, sir, what is the significance of network ID and host ID? Now let me tell you, for class A, the network ID length is 8 bits, net ID is 8, and host ID is 24. So when your network ID length is 8 and host ID is 24, first thing we need to understand is the total possible networks. So total networks possible is given by the formula 2 to the power of network ID length. So in case of class A, what are the total number of networks that are possible to be formed? Is 2 to the power of 8, which is equal to 256. So in class A, totally you can form 256 networks, and total number of IPs available in each network. Number of IPs in each network is given by a formula 2 to the power of host ID is given by a formula 2 to the power of host ID, which is equal to, in class A, the host ID length is 24. So we will get 2 to the power of 24. So in each network, we are going to have 2 power 24 addresses. So class A is going to have large number of IP addresses, but in class A we have only 2 power 8, which equal to 256 networks. You can just try to calculate the product of or the value of 2 power 24. So you will definitely have a very high amount of IPs available in class A. Now let us look at class B. Here the length of network ID is fixed as 16 bits or 2 bytes. In the same way, the length of host ID is 32 minus 16 is equal to 16 bits. So total number of networks in case of class B, we will have 2 power network ID. So we will have 2 power 16 networks, and number of IPs in each network is also 2 power host ID, which is 2 power 16. So each IP will have, each network will have total number of 2 power 16 IPs. So here the same number of networks at the same time, each network will have this 2 power 16 number of IPs. Coming to the class C, the length of network ID is 24 bits. So total number of networks which can be formed by a class C is 2 power 24, but the host ID length is 8 bits. So total number of IPs in each network is 2 to the power of 8, which is equal to 256. So class C is a type of addressing in which we will have more networks, but each network will have only 256 IPs. The class D and class E, here class D is used for multicast addressing, where we try to send the same information to multiple devices. Here the in the last case, which is class E, which will be used for the broadcasting and future reserve sources. Okay, we will not be mentioning about the network ID length and host ID length in specific. Okay, so this is a brief about classful addressing, and let me tell you, one of the important addresses which you have to use is when you have to broadcast a data to all the systems in the network, we have to keep the destination address as 255.255.255.255. That is, all the bits in your IP address is mentioned as 1. We call it as broadcast address. This is a special type of address. And how do we get the first address in a given network? By keeping network ID bits as it is and making your host ID bits as zeros. That is called the network address. Okay, so these are the few important things that we have to remember in case of classful addressing. Now classful addressing has got some limitations. That is, here in class A you will have 2 power 24 IPs in each network, which will be a very big one. And if a company takes 2 power 24 IPs, it may be only using 2000 or 3000, and most of the remaining IPs remain idle. In case if it goes for class C, it will get only 256 addresses. And in case if it is having a 2000 systems, definitely they have to take 8 sets of class C addressing, and they may not get the same continuous sequence of IPs. So here, these drawbacks in the classful addressing can be overcome by using an addressing mechanism called classless addressing. Let us look at it. The classless addressing is referred as classless interdomain routing mechanism. If you could find in your previous slide about classful addressing, you could find there the length of network ID and the length of host ID bits are fixed. That is, for A, it is 8 bits of ID, network ID, 424 bits of host ID. For class B, 16, class C, we had 24 bits of network ID and 8 bits of host ID. Now, in case of this, you could find either shortage of addresses or excess of addresses. To overcome that problem, we are adapting for classless interdomain routing. Okay, so here, instead of representing only as the 4-byte dotted decimal notation, what we try to do is, along with dotted decimal notation, we have a value called /x. Here, the X tries to indicate the subnet portion of IP address, which is similar to the network ID, but it is not mandatory that the subnet portion has to be a multiple of 8. It can be of any value from 1 to 32. So this flexibility is given by classless interdomain routing. For instance, you take in this example, here the length of subnet ID is 23, which is not a multiple of 8. And here in this case, the total number of networks formed is 2 power 23, and each network will have 2 power 32 minus 23, 2 power 9 IPs. The only difference is, instead of calling it as network ID and host ID, we call it as subnet part and host part. And the drawbacks which we have in your classful addressing can be overcome using classless interdomain routing. Now, how do we get an IP address is one of the interesting questions. For instance, you people are working for an organization, and in your organization, there will be people who will be taking care of the network issues and the issue of IP addresses and the other internet issues. We call them as system admins. So in case you want to get your IP address manually, your system admins can help you in this. But if not, you can also get this IP address by clicking on your network connection and your connected network and click on the properties. You could find a IP address details. For instance, from the system which I am connected, you could find here the IP address is mentioned as 192.168.0.103. So click on the properties of the internet to which you are connected, and you could find there what is your IPv4 address and how you have in future we will be connected with IPv6 address, and then what is the protocol Wi-Fi which I am using here, and also the MAC address, that is my system MAC address, will be known when I go for the details. And here you could find a particular term called IP assignment done by automatic dynamic host configuration protocol. Let me just have a look at it before we move to the next topic. Okay, so the topic which we would like to discuss here is called dynamic host configuration protocol, which actually does not require a manual intervention, and it will try to assign an IP address whenever we try to join ourselves to a network. And this IP address is assigned to us till we are part of the network. So that is the reason why we can also refer to as plug and play. For instance, I've just joined a network. I'm trying to use the Wi-Fi. I'm given a particular IP address. Once I move out of it, that IP address becomes free, and another person who tries to connect to it can be assigned that particular IP address. But if I'm a fixed user, for instance, I'm using my Wi-Fi at my home, so whenever I try to connect, that particular IP address will be assigned to me, right? So dynamic host configuration will try to help us to assign a particular IP. And let me tell you, for communicating to any device or to be a part of network, every host should be assigned with one particular IP address. Now the one which is helping us to get the IP address assigned, we call it as dynamic host configuration protocol. Now let us look at an example where I have just come from outside and I want to join to one of the networks. So a new client here would like to get an IP address. Now how do we get an IP address assigned to it. So once I join a particular network, I don't know who is the DHCP server which will be alerting me the IP address. So what I do here is, first step, I will try to broadcast a request saying that, hey boss, I have just joined the network and I need an IP address. So do we have any DHCP server in this network? So the request which I am making a broadcast to all the devices in the network, we call it as DHCP discover. This is the first step in the process of assigning an IP address by DHCP. Now this particular request is forwarded to all the devices in the networks, and one of the router which is acting as a DHCP relay agent might be receiving that request and forward it to the DHCP server. Okay, so this is the first step what we have. In the second step, we could find the DHCP server offering us an IP address saying that, hey boss, this particular IP address is available and you can be using that particular IP address, and I am the DHCP server. So this particular request the info will be shared to the device which is actually trying to connect to the network. Let me show it in the next slide. So first, once I join to a particular network, I will make a broadcast request of, I want to discover who is the DHCP server. So what I'm doing is, I don't know my IP address and I am sending the destination, that is to all the devices in the network. Along with IP address, I'm mentioning a port number. Okay. Now, once this server receives that particular discover request, what it is trying to do is, it is trying to offer me an IP address. For this, it is trying to give me one particular available IP address. And once I receive an offer from the DHCP server, and I know that it is the device which is actually trying to provide me the service, so then once again I'll put a request, sir, I need an IP address so that I can utilize the services. So then the DHCP will try to confirm to me that this particular IP address is available and you can use to the services. So totally you could find first a request from the client to the DHCP server, which is called discover through a broadcast, and DHCP server confirming that it is the server which is available to assign the IP addresses, and the particular IP address is available, and then the client puts a request saying that please allot me that particular IP address, and finally the server confirming that you are being assigned with the following IP address. So totally, to get an IP address in a dynamic way using a DHCP, we have 4 steps, which is the discover, then offer from the server, then a request from the client, and finally the acknowledgement from the server. In short, this total process of IP assignment using DHCP, you can call it as, in simple, DORA: discover, offer, request, and acknowledge. Is it fine? Right. Last thing we would like to discuss here is, how does network get one particular IP address? So sometimes we would find like a local ISP trying to get bulk IP addresses from the DHCP server, and then it tries to allot that particular IP addresses to different devices, like commercial users or residential users. They try to bulk purchase like 500 or 1000 IPs, and then they'll try to sell to the different customers, giving 1 or 2 IPs to each of the customer. Now this is how we will try to find how a subnet will form. For instance, a network having 1000 IDs, a subnet purchasing 250, and then it is once again trying to divide into smaller units. Similarly, an ISP purchases a big volume of IP addresses, and then it will try to divide into multiple parts and try to assign each part to one of the organization. In this example which you are seeing on the screen, they have been provided with So prefix length is 20, or you can say subnet length is 20. So the total number of IP addresses available with it is 2 power 32 minus 20, which is nothing but 2 power 12. So this particular company or an ISP purchased 2 power 12 IPs, and then it is trying to divide these 2 power 12 IPs among 8 organizations, which can also be represented as 2 power 3, so that each organization will get 2 power 9 IP addresses. So we start with, this is the total original IP address, and then we could find a split among those IP addresses among the multiple nations. Now this is how we could find an IP addressing being implemented. So first we try to understand what are the two classes of IP addressing, that is classful addressing. What are the different classes? How many networks exist? How many IPs exist in each network? How do we identify a given IP address? For instance, I got an IP address like 150.20.20.30. Can someone say what's the class? Simple. Look at the first byte. It is 150. It is in the range of 128 to 192. So we can directly say that it belongs to class B. In case if it is in binary, my first 3 bits are 110, the first 2 bits are 1 and third bit is 0, you can directly say that it's a class C. So based on the first byte or the bits of the first byte, we can identify to which particular class an IP address belongs to. Then we try to discover or the drawbacks in the classful addressing by discussing classless addressing. Next, we try to discover or discuss how do we get an IP address using a dynamic host configuration protocol, and what do we mean by dividing of the network into smaller subnets so that we can share the total IP addresses among multiple organizations. The next class we'll try to discuss the topics such as network address translation, and we'll also try to understand the next version of IP addressing called IPv6, and how do we convert or how do we make a transitions between IPv4 and IPv6 networks. Hope you people have understood the class. We'll come and meet you in the next class. Thank you.